So this is trig lesson 3, and it's all about the trig ratios. So back in Math 10C, we did SOHCAHTOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. There's our SOHCAHTOA. Now, we've created these 3 other ratios that we're going to see this year, which are cosecant, cosecant, secant, and cotangent. The cosecant is 1 over sine. If sine is opposite over adjacent, this then just becomes adjacent over, sine is opposite over hypotenuse, so if we flip it, it becomes hypotenuse over opposite. Hypotenuse over adjacent, and instead of opposite over adjacent, adjacent over opposite. Now, the way to remember which one goes with which, cotangent and tangent go together because they both have tangent. Secant and cosecant, how do you remember this? There's one co in every pair. So the cosecant has the co, so it has to go with the thing that doesn't have the co, which is sine. Secant, no co, so it needs a co, it gets its co from cos, or cosine. So that's the way that works. Now, instead of opposite and adjacent, in trig now, we just start using y, x, and r. So this would be my opposite, this would be my adjacent, and this would be my hypotenuse. So sine is, instead of going to be opposite over hypotenuse, is going to be y over r. Cos is x over r. Tan is y over x. The reciprocals are just going to flip each of our ratios like that. Now, some students use a phrase like 7 yellow rabbits to remember sine is y over r. What I like to do is have sine, cosix, tannum. And what that means is the sine is the y value over the r, cos is the x value over the r, and the tan is the slope, or m, which is y over x. Change in y over change in x. And since we remember that, we can go there. The signs of the trigonometric ratios. We've already dealt with sine and cos and tan back in Math 10C, but we're just going to, or 20-1, diagnose them a little bit differently. It's going to be x over r. X and r are both positive in this region, so the whole ratio will be positive. Tangent is y over x, positive over positive. So sine in this case is still y over r. But now the y is positive, the r is still positive, so it's positive. Cos is x over r, but x is now negative. And a negative divided by a positive is negative. So my cosecants are going to be negative in quadrant 2. Tan is going to be y over x, positive, negative, negative. So tan is negative in there as well. Just sine is positive. In quadrant 3, both y and x aren't both negative. The rate r is still positive. But if I have negative y over a negative x, that becomes negative divided by negative, which is now positive. Quadrant 4, the sine value is y, still again, y over r. But now this is negative over plus negative, positive over plus positive, and negative over plus negative. Because the y is still negative, but the x is now positive. That makes the tangent negative down here. So, sine ratios are positive in 1 and 2. Cosine ratios are positive in 1 and 4. The tangent is positive in 1 and 3. So they're all positive in quadrant 1. And then each of them is only positive in one other place. These ones are negative in 3 and 4. Cosine is negative in 2 and 4. And the tangent is negative in, oh, shoot. This is supposed to be 2 and 3, not 3 and 4. Better. And the tangent is negative in 2 and 4. Yeah, that's right. So the easy way to memorize this is cast. Trick is you have to start with down here. Another way I've seen students do it is all students take calculus, and then you get to start in quadrant 1 instead of in quadrant 4. But however you memorize it is good. So now I could just type this into my calculator, but we want to just be able to envision it. 280 is going to be there. Sine is negative in that quadrant. Tan of 7 pi 6, this is just going to be past pi 6, so it's right there. This is a positive quadrant for tan. Cos of 10 pi thirds, well, around there's 6 pi thirds, 7 pi thirds, 8 pi thirds, 9 pi thirds, 10 pi thirds, and I'm now in a negative cos quadrant. Cosecant matches with sines. This is like 1 over sine of negative 225. Now, since it's just 1 over, the positive or negativeness of the thing will be the same, not changing. So negative 225 is there, and sine is positive in that region. Cotan of negative 13 pi 6, this is going to match with tan. So there, tan is negative down there, so cotan will also be negative. And secant of 1,000, 360, 720, 280 more than that is down there. Secant matches with cosine, and cosine is positive down here, so this whole thing will be positive. So to do these things with your calculator, all you do is you do the sine of the thing, or the cosine of the thing, whatever the standard thing is, and then if it's a reciprocal, you do your 1 over using your reciprocal button. So sine of 280, that's going to be myself in degree mode. Oh, guess that is right. Negative 0.9848, and that's close. Sine of 270 would be negative 1, so that's fairly accurate. Oh. Ah. So tan of 7 pi 6th, I need to put myself back into radians. 7 pi divided by 6. Soon enough, we'll get our unit circle, and you won't have to mess around with your calculator so much. But this is going to be 0.5774. Cosine of 10 pi thirds. That's going to be that. Oh, negative 0.5. Cool. And then lastly here, the sine of 90. Even though I'm still in degrees, I've got this really handy trick that I can just go sine 90, use my angle button, tell it I want degrees, and that'll give me a right answer. To do cosecant of 225, cosecant matches with sine, so I go, oh, that's a silly question to ask. Why didn't they just say that? And then I can just type it in right like that. 1 divided by sine negative 225. Throwing my degree symbol just in case. And there we go. It's 1.4142. Cotangent is 1 over tan. So I just go 1 divided by tan. Make sure I'm in radians still. Good. Negative 13 pi over 6 close brackets. Negative 1.732. 1, evidently by rounding. And secant 1000. Secant matches with cosine. So, oh, what a silly question. I'm just going to do that. I don't know why I'm randomly changing to blue. No good reason. 1000 degrees. That's going to be 5.758. Expressing in terms of a reference angle. All we have to do is find the acute angle that it would go with. So 7 pi quarters is going to go around to just before, whoa, actually just before 2 pi. There's 4, 5, 6, 7 pi quarters right there. And so the reference angle is just pi quarters. So this is going to equal cos pi quarters. Oh, except, well, yeah, they're both positive. You have to be careful about whether it's positive or negative. Cotan of negative 100. Negative 100 is going to go to there. That's going to be the same as cotan of my reference angle, which is 80 degrees. For sine of 11 pi halves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's down there. In quadrants 3 and 4, sine is negative. So this is going to be equal to negative sine of pi halves. And if you want to check those, you can check them just by typing it into your calculator. All right. So we are doing these, writing these in terms of a reference angle. So we did a couple of these already. But these questions here, where we are converting from a point to an angle. Our angle is going to go from our initial arm to our terminal arm. And what I can do is I can find the exact value of r. So this becomes a Pythagoras theorem, 8 and 15. So if I were to work this out, I can use this 8 and 15 to find my r. So Pythagoras theorem is this, which is going to be 225 and 64, giving us 289. And the square root of 289 is actually 17. So it's going to be 8, 15, and 17 for my radius. So now I can find these. My sine of theta is going to be 8 over 17, y over r. Cos theta is going to be 15 over 17, or x over r. My tan is going to be 8 over 15, actually negative 15. My cos will also be negative 15. Negative 8/15 for my tangent. And then my alternate are cosecant, secant, and cotan. And then, once we've done this, we can use one trig ratio to find the other pieces. This is a really common diploma-style question. So cotan A is 2, or root 5 over 2, and sine A is negative. So the first thing I do is find my quadrant. If I'm negative, I'm down here. And if cotan is positive, I'm here or here. So the two places where those are true, or both of those statements is true, is down in quadrant 3. So it must be in quadrant 3. Now, since cotan A is x over y, I now know that this triangle down here has a y value of 2 and an x value of root 5. So that's my piece, and then I know that this point must be negative root 5 comma 2. Now I have enough information to find my r. Root 5 squared is 5. This is 2 squared is 4. 5 plus 4 is 9. Square root of 9 is 3. So my r is 3. Now if I want the cosecant of A, cosecant of A is 1 over sine. So it's r over y. My r is 3, and my y is negative 2. And then secant is 1 over cosine of A, or r over x. R is 3, x is negative root 5. So that's how those guys go together. Work through the assignment. If you have questions, as always, come in and get extra help.